Hello everyone. In today's class, we'll be discussing the next topic on square numbers. In the last class, we had discussed what are square numbers, what are perfect square numbers, as well as their properties. Today, we'll be discussing some of the patterns that are being followed or that can be seen in square numbers. So let us begin. So today's topic is patterns of square numbers. So the first pattern is adding triangular numbers. So you might be thinking, what are triangular numbers? So if you remember correctly, in your last class, that means in your previous class, class 7, you have learned something about dot patterns. Okay, even if you don't remember it, let us first see what are these dot patterns and what are these triangular numbers. So let us arrange some numbers in dot patterns as triangles. There will be some dots which will be in the shape of a triangle and they will represent some numbers. Say for example this 1, very simple, a dot. Then 3, it can be written as a dots and be represented in the shape of a triangle. Similarly 6, 10 and 15. If you see carefully, all these triangles are what type of triangles? They are right angular triangles. If you can see it carefully, I'm showing you with the cursor. Except this one, the rest of them are all in the shape of triangles and they are all in the right angled triangles. So in this manner, we can represent the numbers in the pattern in dot patterns in the shape of triangles. But remember one thing, not all the numbers can be represented in this way. We cannot represent the numbers such as 2, 4, 5, or here 7, 8, then 11, 12, 13, 14, no. Up till 15 we have shown here. And up till 15 only these numbers, 1, except 1, we will leave this one. 3, 6, 10, 15, only these numbers can be represented as triangles in the shape of the triangle by using the dot pattern. So the first pattern says that how can we add these numbers? Let us see. If we combine two consecutive triangular numbers, we get a square number. If we combine two consecutive numbers, these are the numbers, triangular numbers. If we combine means if we add, suppose if we want 3 plus 6 or 6 plus 10 or 10 plus 15, these are consecutive numbers, right? We cannot do 3 plus 10 or 3 plus 15. That won't be consecutive. Consecutive means then neighboring, nearby number. Clear? So what if we add them? If we add them, it will form a square shape. If you can see here carefully, 1 can be added to 3. So if we place this dot pattern in this gap, it will form a square. So we had 3 and 1 more added, so it will be 4. And we know 4 is a square number. So the main thing here is, if we add two such triangular numbers, then the resulting shape will be a square. From a triangle, it will turn to a square. And as soon as it turns to a square, that number which it represents will be a square number. Say for example here, as I have said, 1 plus 3 it is 4, then 3 plus 6, but yes, remember consecutive numbers. You cannot jump over here. These are consecutive numbers. 3 and 6 we can add, then 6 plus 10 we can add, you can see here, and all of them forms a square. So since it forms a square, so the resulting number after addition that we get is a square number. Clear? So moving on to the next pattern now. Numbers between square numbers. We know what are the square numbers, 1, then 4, then 9, but there are also numbers in between them. What about them? How many numbers are there in between them? This also can be found out with the help of some formula and following some patterns. So let us see. The pattern between two consecutive square numbers is given below. Say between the numbers 1 and 2, if you have to find the consecutive square numbers between the squares of 1 and the squares of 2. How many are there? 1 square is 1 and 2 square is 4. So in between them, how many numbers are there? We can find out by multiplying with 2. 2 into 1. Here 1 will represent what? It will represent n. And n will be this number. 1. Between which numbers we want? N and n plus 1. N is here 1 and n plus 1 will be 1 plus 1, 2. So between 1 square and 2 square, if you have to find how many non-square numbers, they are called non-square numbers. Since they are not square numbers, so they are non-square numbers. So how many are there? 2 into 1, 2. Similarly, between 2 and 3, 2 into 2, because here the n is 2 and n plus 1 is 3. So that will be 4. Similarly, between 3 and 4, n will be 3 here. So there will be 6 non-square numbers. Between 4 and 5, there will be 8 non-square numbers. So what can we say from this pattern? If you see carefully, we can say that there are 2 n non-perfect square numbers between the squares of the numbers n and n plus 1. 2n. Here you can see the formula 2 into something, 2 into something, 2 into something, 2 into something. So these are what? These are nothing but n. And n are nothing but this. 1, 2, 3, 4. So, and n plus 1 will be 2, 3, 4, 5. If this is n, n plus 1 is obviously 2. Because if 1 is n, so n plus 1 means 1 plus 1, that will be 2. Clear? So, between any two numbers, that is, we have represented in general form, that is n and n plus 1, how many non-perfect square numbers are there? There are 2n non-perfect square numbers. Because this is the formula through which you can find how many non-perfect square numbers are there. That is 2n. Clear? So in this pattern, we can find out how many non-square numbers are there between two square numbers, consecutive square numbers. Clear? Now moving on to the next pattern, adding odd numbers. So how can we add the odd numbers and get a square number? Let us see. Let us consider the sum of the following successive odd natural numbers. Here the word successive is used. So you might be thinking, what is successive now? It is similar to consecutive, but yes, it's almost alike meaning word, but you will be seeing just now what it actually means. So leaving this one we know already, 1 square is 1. Next one, which is the next odd number after 1? 3. So these are the successive odd numbers, means which comes next, that is the successive. Clear? That is the meaning of successive. So if you see 1 plus 3, we get what? 4. 4 is nothing but 2 square. Similarly, 1 plus 3 plus 5. If we carry on successively adding the odd natural numbers, whatever resulting number we get, that is the square of a natural number. You can see here the next one, 1 plus 3 plus 5 plus 7. Then 1 plus 3 plus 5 plus 7 plus 9. Whenever we add the successive odd natural numbers, we always get a square number. So what can we derive from here? We can say that if a natural number cannot be said as a perfect square number unless and until it can be represented as a sum of odd natural numbers, successive odd natural numbers. Clear? Say for example 24. 24 is not a perfect square number. Why? Because we cannot represent them as 1 plus 3 plus 5 plus 7. We cannot break it down or express it in terms of successive odd natural numbers. Clear? So the thing is that if a number has to be a perfect square number, then it has to be expressed as a sum of successive odd natural numbers. One more thing we can derive from this pattern is that the sum of first and odd natural numbers. Why have used the word first? Because we will be counting from 1 itself. Next thing is that odd natural numbers. Yes. Say we are given find out if the question has been asked, find out what is the sum of first 5 odd natural numbers. How can we find out? We have to add it, but there is one easy formula for that. The formula is n square. We have been asked 5, so n will be here 5. So 1, 2, 3, 4, 5. That means till 9. So if you have to say first 5 odd natural numbers, if you have to find out the sum, just put 5 square. That will be 25. And if we add also 1 plus 3 plus 5 plus 7 plus 9, we get 25. So the formula is clear to you. So that's it. So in this class, we'll be discussing only 3 patterns of square numbers. In the next class, we'll be discussing the next 3 patterns that is given in your textbook. So I hope you all have understood it. You please again go through your textbook and practice for yourself and try to see. I've given only till 25 or up to a certain limit, but you can try it out with other numbers as well, so that you can understand by yourself that how this pattern actually works. So I hope you all have understood today's class. So that's it then. Thank you and have a nice day.